Okay, so, well, I just muted myself for a minute. We're subtracting these here, so we need the denominators to be the same. Now, most likely, we're not going to do anything to the numerators, because if we tried to factor or rewrite them as sets of parentheses, well, if we're going to add or subtract them, we're going to have to undo that. So we won't factor the top. We won't mess with the top until the very end with factoring, but we will factor the denominators. So when we look at the denominator here, the first one, 2x minus 2, what can we do to factor it? Yes. Thank you. We can factor out a 2. There's a 2 in common. And if I factor it out, if I factor 2 out of 2x, I'm left with x minus 1. 2 out of 2x gives me just x. 2 out of 2 gives me 1. Now we need to factor the other one. X squared minus 4x plus 3. Since the 3 is positive, the signs would be the same, and they match the sign of the middle term, which would be negative and negative. Now the factors of x squared, well, there's only one set, x and x, and the factors of 3, 1 and 3, there's only one set of factors. Now at this point here, like I said yesterday, what we can do is now we would go to least common multiple, and I would set the 2 out, and we would go through finding the least common multiple. But I don't like that method as much. Almost like the judgy neighbor setup, or kind of looking at the other one, seeing what do they have that I don't. So if we looked for the one on the right, so if we're looking at this one here first, well, he looks over here, and the denominator looks over to the other one and says, okay, what does he have that I don't have? So we look at this one here. What does this one have that this one doesn't? It has a 2. We want that. Well, it also has the x minus 1, but we already have an x minus 1, yes? So the only thing it has that the one on the left right has that the one on the left doesn't, let's see here, okay, one on the left has that the one on the right doesn't, is the 2. That's it. Because the 2 is the only thing that this one has that this one doesn't. Okay. Now we're going the other direction. So we want to see, what does this denominator have that this one doesn't? X minus 3, so he wants this one. And we have to multiply it on top and bottom so we don't change the fractions. Because really, anytime we multiply something over itself, well, 2 over 2 is just 1. It's a fancy way to write 1. And like we talked yesterday with addition, we don't multiply through the denominators. So I'm not going to multiply x minus 1 times x minus 3 or any of these out. Because when we get done, we're going to have a fraction. And if anything reduces on top and bottom, well, I need the denominator already factored out, so things will simplify. But unfortunately, we will have to multiply out on the numerators. The numerators we will have to multiply through. So I'm going to have to distribute this here. We'll have x times x, which will give us x squared. X times 2 would be plus 2x. I have to do the same thing with negative 3. Negative 3 times x would be negative 3x. And negative 3 times positive 2 would be negative 6. So we have to multiply through. The same thing with the other side. We're going to have to multiply each term by 2. 2 times negative 2x would be negative 4x. 2 times negative 1 would be negative 2. And we have to do this with the numerators because, again, if we're going to add or subtract, I can't have them being multiplied together. Yes. And that's what I would do next. Would combine like terms, which would give us x squared. Well, 2x minus 3x would be negative x minus 6. Now on our other one, negative 4x minus 2, those are not like terms. So we can leave them alone. Questions on this here? Now we're almost done. The next thing we need to do is subtract. Now when we subtract these, we need to be very careful about our signs. Because when we subtract something, we're subtracting everything. It's almost we're applying a -1 to each of the signs. Because here we're subtracting negative 4x, and we're subtracting -2. We're subtracting both of the terms. So if you're not being careful and not applying that negative through or applying it to each one that we're subtracting, it will change your answer. Because when we're looking at this here, really, what we have on top, well, x squared, plus minus x minus 6. Well, I don't really have negative 4x because we're what? We're subtracting 4x, yes? Well, a negative does what? Makes it positive. And we're also subtracting 2. Yes. And you need to be careful with this here. I've seen it, and this is back in August when we first started about adding and subtracting polynomials. And I would intentionally put some of the subtractions together, and y'all would get the first sign, so you would get 4x, but you wouldn't get the 2. You'd leave it as -2, which would change your answer. We've got to make sure when we're subtracting that we change those signs. Because if it had been +2, we would actually be subtracting. It would be -2. We've got to make sure we have the correct signs when we're subtracting. It's easy to flip the signs or not change them properly. Okay. Now we can just combine our like terms. Well, there are no other terms with x squared, so it's just x squared. Negative x plus 4x would be plus 3x, and negative 6 plus 2 would be minus 4. I don't know what I'm writing. Yeah. Like I said earlier, I need to be careful when I'm thinking and writing at the same time. So we got down to this here, yes? Except for that 3 that for some reason became a 2. We're good with getting to this here, yes? Now, always, especially on the homework, if the numerator will factor, you need to factor it. Even if it's not going to have any like terms, we still need to factor it, just in case. So since the 4 is negative, our signs are opposite. Because the only way to get a negative number is if the signs are opposite when multiplying. Well, the factors of x squared are x and what are the factors of 4 that we can use? Well, 1 and 4 or 2 and 2. There's going to be 1 and 4. Yes. And the 4 would be positive and the 1 would be negative. Okay. Well, that doesn't really help us, does it? Wait a minute. These are the same on top and bottom, so they would cancel, leaving us with just x plus 4 over 2 times x minus 3. And this here would be the answer. Now, because something simplified on top and bottom, we have a restriction. And especially the homework on Big Ideas Math is going to ask you for this restriction. It would be. If we're trying to see what value of x is going to make x minus 1 equal 0, well, that would be when x is equal to positive 1. Because x equals 3 is a restriction, but since it's still left in the equation, or not equation, or expression, we're not going to list it, or at least according to the book. Questions on this here? Okay. So we're looking at another one, and again, we're not going to do anything with the numerators. We're going to leave them alone. But we do need to simplify the denominators. We need to factor those, if possible. X squared minus 3x plus 2. Well, since the 2 is positive, the signs are the same and both negative because the middle term is negative. Factors of x squared are x and x. Factors of 2, 1 and 2, because that's the only way we can have it factored. If we check it, it would work out, and we would get a middle term of negative 3. Now, how about the other one, 2x minus 4? We can factor a 2 out, which would leave us with x take away 2x minus 2. All right, let's see what we need to do to make the denominators be the same. So what does the left one have that the right one doesn't? Yep, so I'm going to multiply it on top and bottom. Now what does the right one have that the left one doesn't? Any questions on any of this here? Now, like this one here in the last one, when we do this multiplication on the right-hand side, in the numerator, we're going to get a quadratic, yes? Because we have x and x. These two binomials, when we multiply them together, we will get a quadratic, a degree 2, yes? Would you all agree with that? Kind of like with the last one? Now, the reason, again, we want the least common one was if I had another set of parentheses with x multiplied in there, well, it wouldn't be a degree 2 anymore. It'd be a degree 3 because we'd have 3 variables being multiplied together. Well, that's going to make it harder to solve. This is kind of why we do this, have the simplest one. Because it would work out that whatever we multiplied in extra would have to come back out. So on the denominator, we'll have 2 times x minus 1 times x minus 2. In the numerator, well, 2 times 5x is 10x. 2 times negative 1 would be negative 2. That's not too bad. All right, let's look at this one here. We can say there are parentheses around this here, and we're going to use our distributive property. So negative 2x times x is going to be negative 2x squared. Negative 2x times negative 1 will be plus 2x. Do the same thing with negative 1. It should give us negative x plus 1. Now we can combine our like terms. Well, we'd have negative 2x squared. Well, 2x minus x is going to be plus and minus 1. Eventually, yes.
Oh, okay. I think it's not going to do
We haven't changed the signs yet. It just worked out the x became positive because 2x minus x. Now, when we subtract these, what's going to happen to the signs of everything in the numerator of the second parenthesis? They're going to change, yes? They're going to go from positive to negative or negative to positive, yes? Now, if you're able to keep that straight, as we do this here, well, negative would make it plus 2x squared. Then what would we have? We're going to change everything in here. Now, if you know that's going to be a little hard to keep straight, don't do it that way. Rewrite it as negative 2x squared plus x minus 1. Rewrite it with those parentheses if you know you're going to have trouble keeping track of all the sign changes. Rewrite it like this here. And then change those signs. Apply this negative to everything inside here. So the negative gives us plus 2x squared. Negative and a positive gives us negative x. And then we have our plus 1. So if you need that extra step to make sure that you have the signs correct, I would do that because it's going to be the difference between getting these answers correct and getting them wrong. Because one sign change makes a world of difference. Any questions on how we got to this point here before we start combining like terms? Okay. Now, we're going to combine like terms and write it in order of number theory. So 2x squared would go out first. Now 10x minus x would be plus 9x. Negative 2 plus 1 would be minus 1. And this is it here. Now, will the numerator factor? No. Because there's no way I can take the multiples of 2 and multiples of 1 and somehow make 9. It's a little bit too far away. So this here is our final answer. Any questions on this here? Any questions on anything we've done so far? All right, let's continue on. Let's look at number 7. Because I think this is, yep. Find the sum or difference of these here. Now again, I said we won't really do anything with the numerators because we'll keep them the same. Now 3x squared, well, it's a term by itself. Right, we can say 3xx, but 3x squared will be the same thing. Right, 9x squared and 12 can be reduced by 3, leaving us with So is 3x squared minus 4 a difference of perfect squares? Well, no. So can we factor it? Well, no. Not with whole numbers, because we'd end up having to deal stuff with 2 square root of 3 over 3. So it's not rational. So this is as simplified as it gets. Okay, I'm going to center this up on my board so I have a little bit of space. Now we need to make the denominators the same. So what does the left one have that the right one doesn't? It has one thing. Because, yep, it's the x squared. Because our x squared over here is trapped in with the 3x minus 4. That is a term. Now it does, they both have a 3, but they both don't have an x squared. They don't have a 3x squared. So the one on the right is missing that x squared. Now the one on the left is, well, missing the whole 3x squared minus 4. So even though they both have an x squared, it's the placement of that x squared that makes the difference. So we're going to treat the 3x squared minus 4 as a single term. Now this makes the denominator 3x squared times 3x squared minus 4. 3x squared times 3x squared minus 4. Now the numerator of the first one here, we're going to have to multiply both of these by 1. Which would just be 3x squared minus 4. Yes. Because x squared times x would give us x cubed. And last but not least, we need to add the like terms together. What should be? X cubed plus and that's as simplified as it gets. Now, if we had another term, we had an x term on top, then we would look to see, could we factor this? But with 3 terms, x cubed plus 3x squared minus 4, it's not factorable in this way. Questions on this here? I think, yep, this one here is the last one we'll look at. And I find this one a little bit more interesting than the one we skipped earlier. That was just 7 and 4x or something like that. Now again, the numerators, we're not going to do really anything with them. X and 5, we're just going to leave them alone. Now we do need to factor the denominators, x squared minus x plus or minus 12. That said plus. Now because the 12 is negative, the signs are opposite. They're automatically opposite. It doesn't matter what the middle term is. Now the factors of x squared are x and x. What are the factors of 12 that we want to use? 3 and 4. Which one will be positive and which one's negative? Yes. Let's look at the other one. 12x minus 48. We can factor out the 12. There's 12 out of 12x will leave us with just x, and 12 factored out of 48 is minus 4. Okay. What does the one on the right have that the one on the left doesn't? Yep, so here we'd have an x plus 3 and an x plus 3, yes. And the other side would have 12. And really this is just making the denominators be the same. What does one have that the other doesn't? And if it doesn't have it, we multiply it. We give it to it. So the denominator is going to be 12 times x plus 3 times x minus 4 in both cases. Now the numerators will have to multiply. Well, 12 times x is 12x. Here we're going to have to distribute the 5. 5 times x would be 5x. Any questions on this here so far? Well, 12x plus 5x is 17x. Can we factor this at all? Why not? Right, 17's prime. So this is as far as we can go. And we don't have to list any restrictions, at least according to the book, because, well, they're all still there. Yeah. It would be -3 and 4 if we wanted to list them, but we don't have to. Questions on this here?